Good day, everyone. Welcome to Learning to Understand Electrical Principles. What I aim to teach in this series of videos is what is electricity and how it works in electrical circuits. And we're going to be proving the different laws and all these things to help you get a real understanding of the subject. So first of all, let's start off with the very basics. Let's say we have two atoms. One of them has 5 electrons, and the other one will have 3. So this has 5, and this has 3 electrons. Now, so we can agree that this one will have a greater negative charge than this one. This one will be more positively charged. Now, that isn't to say that this is positive and this is negative, and it gets a bit more complicated, but the real basic understanding you need to have is this is more negative and this is more positive. And what these atoms like to do is they like to transfer an electron there. So we'll have a new electron here. And that means this will now drop from 5 to 4, and this will go up from 3 to 4. And then they are equal. So the charge here will then equal the charge here. But before they had the same charge, when this one had 5 and this one had 3, there was a difference of potential. And that's essentially what we call voltage. Well, no, that's supposed to be an L, my bad. So this is what we call voltage. Voltage is the potential difference between two regions. It's normally the highest potential to the lowest potential. If we think about it in terms of a mechanical circuit, voltage would be, let's say, the change between potential energy. So if we were to place a ball up here that's 1 meter in the air, it's 1 meter in the air. Let's say it has a potential of 10 joules of energy. And we put a ball on the ground that has 0 meters. This will then have a potential of 0 joules. So the total difference between these two, total change in energy, is going to be equal to 10 joules of energy. That is essentially what voltage is in a circuit. It is the total amount of potential difference. So in mechanical, the total difference in energy, and even in electrical kind of, yeah. Now, what this voltage does is this potential difference causes atoms to be, not atoms, but electrons to be transferred from one atom to the other. And the transfer of these atoms is the current of a circuit. It's the current of a circuit. But then these atoms will always be slightly opposed. There are forces like the strong atomic forces, strong nucleus forces, and all these things, trying to stop the materials from moving, trying to keep these electrons contained. And those forces all add up to cause something called resistance. Now, the unit for voltage is volts, so V. And also the symbol of voltage is also V. Now, current is represented by I, and its unit is amps, denoted with an A. So this is V, and it's denoted with a V. And then resistance, we always signify with R, and that's measured in ohms. Now, let's take a look at this in an actual circuit. Let's say we have a battery. Okay, maybe delete that. Let's say we have a battery. This long side is our positive side, or the side with the greater number of charge. And this negative side is the side with the lower amount of charge. And then we're going to draw a resistor. That is our circuit resistance. Now, the second we connect a battery to a circuit, we have a voltage rise. So voltage floods into the system. Basically, the battery is the thing that lifts this ball all the way up to its point. And we're going to call that we're going to switch this to purple. We're going to say this is our voltage. And we're going to call it the supply voltage, Vs. And you notice the arrow goes from the positive to the negative. I mean, from the negative to the positive. Now, what this voltage then causes is it causes a current to flow. These electrons want to move from this higher potential to this lower potential. Now, just as a quick aside, there is two types of thoughts we have. We have something called conventional current, which is when it goes from the positive all the way to the negative. And that's why I refer to this as the higher potential side and the lower potential side. But then we have something called electron flow, which goes from the negative to the positive, because that's the side that has all the actual negative electrons that flow around. But to stop you from getting confused and all these sort of things, we'll only ever use conventional, as most universities, textbooks, and almost every example I've ever seen uses conventional. So we're going to go from the positive side all the way to the negative side. And we're going to call this our higher potential, and this is our lower potential. But then you notice this also goes through the resistor. And what this resistor does in a circuit is we have all these little electrons flowing, and let's say they're flowing in groups of the two. So it's too wide, they're going in too wide. When we have a resistor, it tightens the entire thing. It stops them from flowing at too wide to flowing at one wide. So now they have to flow one wide. And what this ends up doing is all these slower electrons waiting, then they start doing work. And this work becomes heat. So this resistor starts heating up. That's why I'm going to highlight it in red. It starts heating up. And as this work is performed, it eats up charge. And that causes a voltage drop across it. So if this was our positive side of our resistor, because the current comes in, so this is the higher potential, and then work is performed, so charge is used up. So then we get a lower potential on this side. Then we draw an arrow, and now we've just used up voltage. So our voltage physically drops across this resistor. We call it a voltage drop because work is being done and energy is being used. So let's say our voltage here was equal to 5 volts. What this resistor does is it eats up the voltage. So at this point right here, we'll have 5 volts worth of energy. But at this point right here, we'll now have 0 volts because the voltage is being used to perform work in this resistor. And there will always be 0 voltage going over to the negative side. In any circuit, there should be 0 voltage going into that negative side. And when we look at it basically in this situation, the resistor is the thing that causes this drop. The resistance all causes causes this ball to drop in a mechanical circuit, let's say. Of course, it's not the same and so, but this is a good visual representation. The resistance is what gets this ball from all this energy to its final state, where this can now go into the negative side. So if this side has zero potential, well, the resistance causes all of this energy to be lost, so that we can have zero going into that side. Now, all of these resistance and current and them, they all have a relationship. Now, this relationship can be seen when we say voltage is directly proportional to current, because the greater the amount of charge, the greater the difference in the charge, the more electrons need to flow to make it balanced. If I were to take away this, and instead of having 3, I have 2 ohms. So now, before, when we had 3 electrons on this side, we needed how many? Maybe cut that. We needed only 1 electron to balance it. Now I need this to come back, which gives me 3 on this side and 4 on this side. And then, actually, I'm just going to first add another electron. So this is going to be 6 on this side, so it balances. And then I'm going to take this one across. And now, once again, it's 4 to 4. But you notice I've had to give up 2 electrons because there was a greater difference in their potentials. So the greater the voltage, or the greater the difference in potential, the more electrons are going to flow, which means the more current is going to flow. So that's why voltage is proportional to current. But now current will be inversely proportional to resistance. Why? Well, once again, the amount of electrons that are allowed to flow is based on the resistance. If there is more resistance, there'll be less electrons allowed to flow, which means there'll be less current, because current is the flow of the electrons. So we can put this all into one law called Ohm's law. This is the very foundation of circuits, and this is the law that you'll see creep up into all these other things. So the current in a circuit will be equal to the voltage of that circuit over its resistance. Now we can also rewrite this to say the voltage is equal to the current times the resistance, and that the resistance is equal to the voltage over the current. Now if we go back up here, you can see that R is on the bottom. Oh, by the way, sorry, I messed up here. That is supposed to say 1 over R, because it's inversely proportional. So you can see that here we have 1 over R, and here we have V. So this is proportional, and that is inversely proportional. And it's basically the first part you need to understand about electrical circuits, the relationships between these different components. So the relationship between the voltage, the current, and the resistance.